Hi folks, as you can see by the title there, we're looking at solving some trig equations, this time with multiple angles. We have solved multiple angles before in terms of sine 2x and cos 2x. And 2x might be involved as well, because they are multiples, they're not just single x. So we'll just see how it goes. This should be quite short and sweet, or maybe not sweet for you. So let's see how we're going to proceed here. So when we're looking at double angle with things like sine 2x and cos 2x, so it looks like we've got cos 2x here. As well as that, we usually had something else like maybe cos 2x plus a half sine x equals 0, or cos 2x minus sine x equals 0. But this time cos 2x is in isolation. So we can actually solve that kind of quite straightforward, or in a straightforward fashion. It's easy for me to say that, I know. So what I'm going to do here is introduce the graphs of cos 2x. It's on the left hand side of the equals, and on the right hand side we've got a half. So I've only got two graphs here, cos 2x or y equals cos 2x. That's one of the curvy things. So that's y equals cos 2x, your cosine curve. But on the other side, equals a half. That's really y equals a half. I don't know if you remember what that looks like. Anyway, there's a graph of y equals cos 2x. And it's between 0 and 360. And the reason that there's two complete waves between 0 and 360, I'll just show you that there. Two complete waves. Just think of one being a duplicate of the other. It's because it's 2x. There is two complete waves over the distance, the angular distance, 360. Right. But I know you know that. Okay. So that's y equals cos 2x. So that was one side of the equation, cos 2x. There. So the other side of the equation is a half. So since I've got y equals cos 2x, I need to have y equals a half. And y equals a number. It's just a horizontal line at that specified number. So I'm going to have a line, horizontal line at y equals height a half. I've got it there. So the solutions here is where the line meets the curvy part, the cosine graph, but it's only the x values that we're interested in here, because we're solving just for x. Ultimately, we are solving for x. And just to emphasize it there. There's my equation. Cos 2x equals a half. Right. So we need to isolate x. That's what I'm solving for. So it's only the x values. Okay. So I've tried to highlight here where the line meets the curve, and I'm going to bring it down on the x-axis because that's my solutions. There you go. And because I get such a brilliant graph, and the x-axis represents angles, I'm going to tell you, I'm going to show you the values. 31, 50, 210, 330. They're all in degrees. Okay, that's the solutions of cos 2x equals a half between 0 and 360. Where I included 0, where I included 360, doesn't matter in this case because they're all well within that frame. Right, okay. Are we going to solve it like that? I don't think so, because we were there all day. So we're going to solve it, as it says, without a graph. Okay, here we go. Cos 2x equals a half. Right, things we need to know. Well, we've dealt with the quadrant check in the past. We're going to bring that back, so there's no need to explain that. all sine, tan, cos. Okay, where's cosine positive? What we're talking about positive here, I'll just highlight that. What we're talking about being positive, it's that number there. We're talking about being positive again. Oh, I feel like I'm just explaining myself again and again and again. Right. Where's cosine positive and all in cosine? What's the little formulas? It's a and 360 minus a. Please bear in mind that the small a is a calculator answer, so we need to bring on board small a. So we get rid of 2x and we bring in board a. A is a stunt double, the trig stunt double. It only gets used for calculator purposes. Cos a equals a half. Let's get a in its own. Get rid of that cos thing. So on the other side of a equals inverse cos of a half. And a lot of you like to say cos with a minus 1 of a half. That's fine. Okay, that's fine. But I'm just going back and saying we are not solving for 2x. We're solving for a, the calculator answer. Right. Inverse cos of a half. What do you get? I think you're quite right. 60 degrees. Right, yous have all got your fancy calculators. 6 degrees. Right, that's a calculator answer. Let's go back to the quadrant check here. So we'll get a and 360 minus a. So a is 60 and 360 minus 60 is 300. But we have to bring back 2x because now that's what we're solving for. So it's 2x equals, yep, 60, that was the calculator answer, and 360 minus that. Right, okay, we've got our two solutions for 2x. 2x equals 60, 2x equals 300. But the thing is, we're solving for x, so we need to get rid of that 2. So if 2x equals two numbers, we only get two equations. I think what I need to do here is divide throughout by 2. Okay, so we're going to have x equals 60 over 2 and x equals 300 over 2. And there you go. 60 divided by 2 is 30. 300 divided by 2 is 150. Right. That's my two kind of solutions that were related to my quadrant check. Right. But I think I've got more than two answers. Because the graph that we showed earlier, there was 4 points of intersection. And 30 and 150, they were two of the solutions. So you can see them, 30 and 150. They are there. Right, but it looks like I've got two other solutions. So they might be connected in some way to the 30 and 150. The thing is, your calculator, it doesn't know that you're dealing with trigonometry. Okay, it doesn't know you're dealing with a cosine wave. That's your job. So what I'll try to point out here, the first solution I've got 30, it's actually related to one further on, the 210. And that one upside down y, that's one lambda, that's one period, or that's one wavelength further on of cos 2x. So there seems to be a connection. They kind of look similar. And also, the other solution, 150, it's related to the other one, 330. So there seems to be some sort of connection between my two solutions. Okay, and that connection is they are one wavelength further on. So I need to go and say, well, what wavelength or period, in maths they like using the word period, what period are we talking about here? Well, we're talking about cos 2x. What's the period of cos 2x? And a way to think of that is, well, cos 2x means there's two complete waves between 0 and 360. So what would one wave be for cos 2x if there's two between 0 and 360? Do a little bit of arithmetic here, and you can read that. Right, okay. It says remember here, but whether you remember it or not, I don't know, you might have been listening in the class. Lambda is 360 divided by k. K is the number in front of x. We had cos 2x. Okay, so 360 divided by 2, we get 180. So that's what we are going to add on to our two original solutions from the quadrants, the 13 and the 150. So don't think, oh, where's he got this page from? If you rewind, that's where we ended before we went back to the graphs. So we get 13, 150. So now I'm saying, can we add one wavelength of cos 2x that we just decided that the wavelength of cos 2x is 180 degrees. So we're going to add that 180 degrees to both 30 and 150. So here we go. First one, 30 plus 180. Secondly, 150 plus 180. Okay, simplify them, and there you go. 30, 150, 210, 330. Right, so this is without a graph, but does it agree with the graph? I don't know. But I'm just going to backtrack. 30, 150, 210, 330. And it looks as if it does agree. So it's the x values here. Okay? The x values are the angles. Right, let me go forward. And remember, as always, you can always rewind the video. That's the whole point of this. Right. Okay. So that was the first one. Cos 2x equals a half between 0 and 360. Not inclusive of 360, but inclusive of 0. And we went through all the motions here. Let's go and get another one. So we get tan 3x equals 1. Right. Tan 3x equals 1. Okay. It's tangent. That's fine. Don't care about the 3x just now. We just care about the number on the right hand side of the equals. That's 1. Is 1 positive or negative? Well, it's positive there because we don't have a little line in front of it, which means it was negative. So where is tan positive? I think all in tan. Okay, all in tan, that's fine. There's a little formula, a and 180 plus a. I don't, technically I should have put in there 3x minus a and 3, 6 equals 180 plus a, but I'm not going to. Less is best. Right, let's get rid of 3x. Let's bring on board a. Again, a is a stunt double for 3x. Tan a equals 1. Let's get rid of tan, opposite of tan, inverse tan. Tan with a wee minus 1 of 1. We're working in degrees here. Your calculator should say 45 degrees. Can you double check that, please? It won't have the wee degree symbol, but we'll say 45. So hopefully you've got that there. Right, we're going to take the 45 and but we have to bring back 3x here because a, again, I'll say it's a stunt double. Can you please Google stunt double if you're unsure what I'm talking about here? Okay, a replacement that takes all the blows. We need to bring back 3x. Okay, there you go. So it's going to be 3x equals two solutions, a and 180 plus a, and the a is 45. So, yep, 3x equals 45 and 180 plus 45, 225. Right. This time we're working without a graph. So, how many solutions are we going to have here? Well, a clue to how many solutions you have here is you just look at the number in front of x, and we've got a 3 here, and if you're looking from 0 to 360, generally it's 2 times the number in front of x. So 2 times 3 is 6. Okay, so it looks like we're going to have 6 answers. But what I'm going to do here, I need to isolate x. So I've got 3x here equals 45 and 225. So I'm going to divide both of them by 3. That will get me x on its own. So 45 divided by 3 and 225 divided by 3. So x is 15 and 225 divided by 3 is 75. Right. That's sort of my two working answers I'm going to go for here. Right, so I need to add, I think I've got 6 solutions here. So I need to add on, basically, always go for 360 divided by the x number. Okay, so it's 360, there's my x number. Doesn't matter if we're talking about wavelengths here. So 360 divided by my x number, I'm referring to that as k. I could call it n, I could call it whatever, but it's 360 divided by 3 is 120. So I'm going to be adding 120 on to my first pair of solutions until I get up to 360. And hopefully this one I'll get 6 solutions. So, and like it's saying there, tangent actually has a wavelength, a periodicity of 180. But don't worry about that, because this technique works. Okay, so we're not really talking about wavelengths here. I don't want to get into any more depth in this. You would take me down a cul-de-sac. Right, okay. Let's add 120 in pairs to 15 and 75. Right, 15 add 120, 75 and 120. That's my next two solutions. Right, I'll get 1, 2, 3, 4. I was suggesting I've got 6. So see with the 135 and 195, can you add on 120 again? There. Right, add on 120 again. 255, 315, and just check that those answers, 15 up to 315, just check that they lie actually within the zone here that I'm highlighting, 0 to 360. Looks as if they do. And if you added 120 onto 255 and 315, you would actually be above 360. But you can try it if you want. That's up to you. It's not a case of do it my way or take the highway. You try things out for yourself. Right, so that's our second one there without a graph. Okay, here we go. We got another one here. Oh, and that looks a bit strange. I've got sine of 4x equals 1 over root 2. Don't worry about the 1 over root 2 part. So I'm just going to try and get this into your head. Usually we work in the space 0 to 360. And it's always good to have that in your head, that you're always working there. So how many solutions am I going to have? Well, it's saying it's 4x. So what I'm going to do, so it's going to actually be 4 times 2. So I'm going to have a maximum number of solutions of 8. That's unless I had 0 and 360. But we can talk about that another time. Right, so I think I'm going to have 8. So I don't really want to complicate it that much. So I think I'm going to have 8 solutions here. Right, so I've got 4 sine 4x. Forget about the 4x for now. It's equal to a number. That 1 over root 2 is that number positive or negative? And then I'll be able to go to my quadrant check. All sine, tan, cos. It's sine. 1 over root 2 is positive. Okay, there's sine positive. All on sine. Okay, yep. There's a little formulas. A 180 minus A. So we need to go and get small a, the calculator answer. So get rid of 4x. It's going to be sine A is 1 over root 2. So get rid of sin from the left hand side. So on the right hand side, it's on the inverse sign. And use like saying sine with a wee minus 1, that's fine. As long as we we know what buttons to press or which part of your brain to use. So in this sign 1 over root 2, oh, that's actually a nice number there. That's why I've used it. That gives you 45. Yes, indeed. So we've got our calculator answer. Let's go back up to the quadrants. But the thing is, I need to bring back 4x because A has done its job. So it's going to be 4x equals calculator answer 45 from the quadrant. It's ticked here, and 180 minus 45. Okay, which is 135. Right, that's what I'm going to call my working solution. So I need to get x on its own. So 4x, for 4x to become x, I can only divide here. Okay, so I'm going to divide everything by 4. So if I divide 4x by 4, I get x, and then I have to divide 45 by 4 and 135 by 4. It doesn't matter if you get decimal answers here. That's what happens. Okay. Right. They are now what I'm going to call my two working solutions. So because it's 4x, I double that, and I reckon I'm going to have 8 solutions in my space between 0 and 360. So I need to add on in pairs. Well, technically here is a wavelength of sine 4x. So if I just take 360 and divide by the number in front of x, so sine 4x, so it's 360 divided by 4, 360 divided by 4 is 90, okay? So we're going to add 90 to both those solutions for single x, start adding 90 in pairs. Right, that's my next two pairs. Again, take 90 again and add it to both of those. That's my next two. Take 90 again and add it to both of those. Okay, so see if you added 90 to both of those solutions. So 281.25, if I added 90 there, what would that give you? That would give you 371. Right, so you're well over. Right, but try it anyway if you're unsure. But it looks like I've got 1, 2, 3, 4, 5, 6, 7, 8. And we sort of intimated that or spoke about that there was a possibility there might be 8 solutions because it's saying 4x. And usually it's a good indication it's 2 times the number in front of x. So, and because we've got that there eventually, oh, why don't we just underline it to a lap of honour? So, for us, multiple angle format is usually pretty straightforward. You just bring it back to solving a basic equation. And the only additional thing you're doing here is adding on um, a period of a wave or a wavelength. And with tangent, it's not technically, that's not correct, but it works. So I think I'm going to leave it there. But as usual, you can go back. Okay, that's the whole point of these videos. You can go back and have a wee look yourself. But the best thing is, you need to try these questions for yourself. I've not put any of these questions in ratings, but you have knowledge of ratings. So we're going to leave that there. So if you're watching this, it means you've actually pressed the link. So, oh, it's getting late. Bye for now.